Welcome to the second module of our forensics course. My name is Justin Pineda, and for this module, we'll be talking about investigating network traffic. Right, let's go. So, for the learning objectives, we have six. So, the first one would be to learn the different network attacks, which is an overlap of topics in cybersecurity and ethical hacking and networking courses. And then the next one would be to gather evidence in the physical layer and then learn the different DNS poisoning techniques. Okay, so the fourth one is to gather the evidence in the data link layer and gather evidence from the IDS. And lastly, to be able to document and reconstruct the network evidence. So we set the tone by identifying the different types of attacks and how to gather evidence um, from some of the important parts of the OSI, which for network would be physical and data link. And we'll go to the network layer also, but for this session we'll be talking about physical and data link layers. All right. So for the module uh, two, there will be three core topics. The first one would be network attacks. The second would be evidence gathering. And then the third would be the different network forensic tools and evidence reconstruction. So for the activities that are included in this module, we'll be setting up a start IDS and enable its logging and alerts, and then we'll test it. And of course, what you learned today. All right, so let's go ahead and discuss network attacks, um, uh, which is the first topic and meets the first learning objective and the third learning objective. Okay, so these are the types of network attacks. So usually um, it would be about spoofing, meaning like for example, IP spoofing will be trying to um, yeah, well, trying to mimic and copy a legitimate IP so that the traffic will go to you instead of going to the intended recipient. And then you have router attacks. So router is a layer 3 device, and usually the router attacks would um, uh, are are um, are conducted to reroute the traffic to a different direction or cause denial of service and um, other types of attacks that will derail um, the communication from source to the destination. So it's either I will be able to route it to the IP of the attacker or not not being able to send information to the intended recipient. Right. Third would be eavesdropping, which this is common to listen um, uh, if it's targeted, and depending on the type of network that you have. The next would be denial of service, which is to usually we associate it with the term flooding and eating up the resources of the target or the victim machines. And then we have the man in the middle attack. Okay? So trying to um, eavesdrop and get information that is not supposed to be um, seen or um, should not be um, passed over to a third party. And then we have sniffing using um, packet capture tools and of course, data modification, integrity attack, manipulating the content, and making it making a different message, and the receiver still is able to receive it. Now, why do we need to investigate network traffic? Of course, we want to locate the suspicious network traffic. And again, similar to what we discussed in module 1, if it's not something that is filtered, meaning the tools that you have not been um, tuned yet, and we don't know the patterns of your network, it will be very noisy, and we won't be able to determine what traffic is suspicious, what traffic is normal. But assuming that you already have um, a tuned, customized rules and policies in place, then you would easily be able to detect suspicious traffic. Specifically, like for example, if your the most basic example, if the working hours in the organization is 8 to 5 and you have a spike in the bandwidth um, during midnight, then that would be considered a suspicious network traffic and it would stand out. All right, and know which network is generating the troublesome traffic. So meaning which part of the network, what VLAN segment, what department, and where the traffic is being transmitted to or received from. So is it um, north-south traffic, or is it internal east-west traffic? And then, of course, identify network problems. Not necessarily security, probably just network problems that um, we need to investigate and fix. So the route would be different. Like for example, if it is suspicious network traffic, it will be routed to the security team. If it's a network problem, it will be routed to the networking team. If it's something to do with the tools, probably it will be routed to the um, security engineering team and so on. All right. Now let's go to evidence gathering, okay, which meets the learning objective 2, 4, and 5. So the first thing that you need to identify would be the type of network you have. So the evidence gathering in the physical layer, the first would be shared Ethernet. So it says here that every machine receives packets that are meant for one machine. And this one machine sends a packet with the MAC address, which is the hardware address, with the source and destination to every machine. Now, a machine with a MAC address that does not match the destination address simply discards the frame. Then a sniffer ignores this rule and accepts all frames by putting the NIC or the network interface card into promiscuous mode. So what does it mean? So um, again, um, so if you set it to promiscuous mode, then um, the machine will be able to receive all the packets, because by default, okay, if the MAC address does not match the destination address, it will be discarded. But if you turn the promiscuous mode on, then it will be able to lag all the traffic. And that's the meaning of promiscuous mode here. Okay, so let's define it. So promiscuous mode is the mode of a network interface card or NIC in which the card passes all network traffic it receives to the host computer. So we'll be able to get all the traffic rather than the only traffic specifically addressed to it. Hence, the passive sniffing is possible in a shared Ethernet environment, but it is difficult to detect. Okay. Next would be the switch Ethernet. So the switch Ethernet here, so would be the hosts are connected to a switch So again, this is networking 101, which is a table that keeps records of the MAC addresses of the host machines on the network. Then the switch transmits the data packets to the destination machines using this table. Okay, so this is more intelligent in a sense. So there is organization, there is a table that is being monitored. Now, for a sniffer to work in a switch environment, an extra feature is needed that captures traffic from the source port to the sniffer port. Now, we call this what? We call this PAN, or the switch port analyzer. Now, this is the port that's configured to receive all the packets sent by any source port. So you um, you use and enable the span port. Okay, so you turn the service up. Okay, but again, the this is the feature use if you want to plug in, say, an IDS, intrusion detection system, because we want to make sure that we're able to get all the packets that are passing through. So it's the span port. Okay. Now let's go to some of the attacks. Now, the first attack would be DNS poisoning. So the DNS poisoning, so when we say DNS is the domain name server, or domain name system server. Now this DNS contains the list of um, the host names and its corresponding IP addresses. So instead of us, the users typing the the IP addresses, we just type the URLs, and um, uh, it is mapped, and uh, yeah, it is mapped to its corresponding IP. Okay, so meaning it is resolved. We call it resolved to the uh, IP address. Now, with that background, we know what poisoning is. So when the contents of the DNS server is um, modified, okay, and say you have here facebook.com or other websites, and instead of pointing to the correct IP, you change the IP, and you already have a set up fake website corresponding to that um, real website. So in short, users will be going to that fake website thinking that it is the right or the real website, and providing this information. Okay, there. So that's why it says here you request a user will request to the real website, but the attacker in red, number two, will inject fake DNS entry, and then okay, DNS server will resolve it to a fake website instead. All right. Now for DNS poisoning types, of course, um, there are some variations. You have the intranet DNS spoofing in the local network, and internet DNS spoofing for the remote network, a proxy server DNS poisoning, and DNS cache poisoning. So the concept the same. So for intranet DNS spoofing, that is in the local network, of course, the requirement here is that the attacker must be in the local network and be able to sniff packets. So this method works well against switches with ARP poisoning on the router. So again, when you do ARP, so when we talk about ARP, um, or the address resolution protocol, um, it lists down all the IPs within the network, its neighbors, and other machines in the network, and its corresponding um, MAC addresses or hardware addresses. And if you're able to poison that and change the contents, the mapping of it, then it might um, target the same legitimate destination IP address. But because the MAC address is changed because it's poisoned, it goes to the attacker's machine. So internet DNS spoofing. Internet DNS spoofing in the remote network, the method of DNS spoofing works across networks and is relatively easy to set up and implement. Okay. So here this requires a Trojan to the target machine, okay, and changes the machine's DNS IP address to that of the attacker. So there is another step further. Okay, so it says a Trojan, and it has to be executed at some point, of course. So there is a prerequisite action. The third is the proxy server DNS poisoning. Okay, so this type of DNS poisoning works across networks and is easy to set up and execute. Okay, so again, you send a Trojan to the user machine, okay, and change the um, but this time the proxy server, um, okay, and will be pointed to the attacker's machine. And the last would be DNS cache poisoning. So here, when we perform a cache poisoning, an attacker exploits a flaw in the DNS server software. Again, another requirement, and that can make it accept incorrect information. Okay. If the server does not correctly validate the DNS responses to ensure that they have come from an authoritative source, the server will end up caching the incorrect entries locally and serve them to users that make the same request. So we take advantage of the cache, and usually these are the um, recently inserted entries or the commonly used ones. So that's another variation. Now, let's go to evidence gathering from the ARP table. So we talked about ARP, address resolution protocol, that contains um, the IP and it, its matching MAC address. Um, so the ARP table of a router comes in handy, okay, for investigating network attacks, as the table contains the IP addresses associated with the MAC addresses. So just by simply putting in ARP-A, the investigator can view the ARP table if it's Windows. So this is very important if you want to gather evidence and see the state of the, the, the live host, right, and which IP addresses are they using, so on and so forth. The next would be the DHCP. So when we go to the data link, we talk about the DHCP, or um, it's called the Dynamic Host Configuration Protocol that leases IP addresses to the machines. So instead of setting them manually, you have your DHCP server that provides a pool of IP addresses that are available and leases this to each of the machines. So the DHCP database provides a means of determining the MAC address associated with the computer in custody. And the database helps the DHCP conclude the MAC address in case the DHCP is unable to maintain a permanent log of requests. So again, this would support the items that are in the information that are found in the ARP table. So assuming they match, then you would see, okay, this is what the HCP assigned, this is the MAC address, okay, and then later on, if the ARP table does not match, then probably that's the affected machine, okay, and then you can do your deduction and say, okay, this might be the infected machine, this is where the attack started, and so on and so forth. All right. Now, the next is gathering evidence in your IDS or intrusion detection system. Now, an administrator can configure an IDS to capture the network traffic when an alert is generated. Now, however, this data is not a sufficient source of evidence because there is no way to perform integrity checks on the log files. Okay, so, one of the common ones would be Snort, open source, free to use, and can be easily deployed. So, we'll talk about that later. Now, let's go to the network forensics tools and evidence reconstruction. So, here are the network forensics tools that are available. Some of these are not for the exclusive use of forensics. It can be used for network analysis. It can be used for network monitoring. It can be used for security investigation, not necessarily for forensics alone. So we have TCP dump, WinDump, that collects raw packets that you can use to investigate. That intercept, Wireshark, the packet capture tool, okay, and then similar tools, no, like Soft Perfect Network Protocol Analyzer, HTTP Sniffer, Ether Detect Packet Sniffer, OmniPick, Iris Network Traffic Analyzer, Smart Sniff, NetSetMan, Distinct Network Monitor, and Matic Network Analyzer, NTAP, and EtherApe. Okay. And there are so much more, no? But we just listed some of the known ones. All right. Now let's go to IDS rules. So the IDS will be useful when you use the right rules. No? So uh, that's the prerequisite. Otherwise, it will be very noisy. It will generate so much alerts that maybe false positives. At the same time, um, you want to make sure that only the relevant um, only the relevant um, rules are enabled for you. Like for example, if you have a web server, you have a database, then this rule should be enabled, of course, and the others, okay, um, you can disable or filter which ones um, may be of use to you, specific to the technology that you are using. So, of course, a violation of security policy of the company. All right, so that's one important consideration. Okay, all the well-known and common attempts to exploit the vulnerabilities of the company's network. Now, um, for majority of the IDS available, you will see that there are um, rules that have been created to answer these well-known and common attempts to exploit the vulnerability. So we have these rules already. You can just enable them. And then the last would be the condition in which a user thinks that the identity of a network packet is not authentic. All right. So IDS rules. So we have a separate video about creating start rules. So, but the core principle is that number one, no written rule should extend beyond a single line. That's to be straight to the point, so that the rules are short, precise, and easy to understand. Principle 2, each rule should be divided into two logical sections, which include the header and the options. So the rule header will contain the action, protocol, source and destination IP, and then the source and destination port, the information, and the CIDR, or the classless interdomain routing block. Okay, and then the next would be the options, which include the alert message, what should be inspected, what would be the messaging, if there is a pattern, and other um, operands that you can think of, like will you be screening keywords, will you be screening this and that, so it has to be there. So that's the second principle. Now, let's go to documenting the evidence now gathered in the network. Okay, so here, similar to because previously it's not easy to print out everything and get a screenshot of things. Now it's very easy. You have a snipping tool, get uh, get a visual documentation of your evidence, okay, preserve the logs, make a copy of the logs in a text file, and then um, make sure you label it. Um, then document the evidence gathering process by listing the name of the person who collected the evidence, from where it was collected, the procedure used to collect the evidence, and the reason for collecting the evidence. Now, if the evidence resides on a remote computer, detailed information about the collection and location should be documented. The investigator should specify the server containing the data to avoid confusion. Usually, there is already a document that you will be filling up, okay, so that you won't miss details. And then print out screenshots of important items and attach the records of actions during the collection process. So again, that's part of the template that you have. So challenges in network evidence gathering. Evidence in network now is not static and not concentrated at a single point on the network, which is crucial. Um, Next is the variety of hardware and software found on the network makes the evidence gathering process more difficult because of the lag types. For example, the lag types coming from a Cisco device is different from a Fortinet device, and so on. Um, and that's why, at least when we start investigating, we look at the common the common things like the IP, the the protocols used, the port numbers, and its associated MAC addresses, and so on. Mm. And last would be the evidence reconstruction for investigation, which we will be doing in the latter part. So there are three types of analysis that we have to do. The first one would be the temporal analysis, which produces a sequential event trail. So that's what we want to do, no? Be able to come up with a sequence of events. What happened during this time, during this day, day 2, day 3, until such time that we have detected the attack. Okay, so it sheds light on important factors such as what happened and who was involved. So usually you have a time grid, you have a histogram, so it will guide um, all the stakeholders involved. The second type of analysis that you have to do would be relational analysis. Now, this analysis correlates the actions of suspect and the victim. So, what would have triggered the suspect to do this to the victim? And if you're the victim, why are you the target? So, once the relations are determined, it becomes easier to reconstruct activities because we want to do the reenactment, no? And put the pieces of the puzzles in place. So you have your association and relational diagrams here. And the last would be functional analysis. So the functional analysis provides a description of the possible conditions of the crime. So it testifies to the events responsible for a crime in relation to their functionality. So what are the potential conditions, of the crime? Okay, so if this happened, if route A was happened, would the course of the events differ versus if I chose route B? Okay, and what are the potential gaps in between? Um, what does it make sense? Okay, why did the suspect did not do action B? Why did he do action A? Etc. etc. So that's functional analysis. So we'll do this um, in the latter part. But for now, it's important to define the activities for evidence reconstruction. Okay. So for further reading, so these are some of the useful materials that you can use investigating network traffic for an IP. A very good write-up from IBM. And then you have here investigating attacks with IPS and network forensics using by Faster Capital and network traffic analysis by Rapid 7. Although, of course, they are promoting some of their products, but still, the content is very, very useful. All right. So, thank you very much for listening and viewing this video on investigating network traffic. In the latter part, we will be using some of the tools and we will apply um, the things that we have discussed in reconstructing the evidence gathered. Right? So, again, in Kapampangan terms, at Kenny, yamayayari inka na kung presentasyon. Dakal salamat kay kayo pakikiramdam. Thank you very much for listening and we'll see you in the next video.